All right, hello everybody. We are going to start with talking about your basics of algebra, and mostly what we're going to look at is your order of operations right now. So this is the PowerPoint. So hopefully you have your handout for this so you can fill things out as we go along. Well, work on problems and fill them out later if you need to. So really our objective here is to what we're going to call simplifying expressions. So really when we're talking about simplifying, simplification is to do what we can algebraically to eliminate operators, like try to take care of them if we can, and to try to consolidate down to, like a single number. If we have variables, maybe a single number and a variable, but we're trying to eliminate having tons of numbers, tons of variables, and tons of operators. So we're trying to simplify that and get it down to just a few as best we can. So to start this, just quickly over exponentials and exponential notation in case we need to go through this. So if you have an a to the n, sometimes it takes me a minute to grab my tools here. This a to the n, a represents a number and n represents a number that's called an integer. So just as a reminder, so our integers are our numbers like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, yada, yada, yada. So a lot of times people like refer to these as whole numbers, but whole numbers have to be the positive versions. But we're looking at, like, this is what you call your natural numbers, their negative counterparts, and 0. So that's what we mean by integers. We're mostly going to deal with these integers for right now. But anyways, if we have an a times a times a times a times a, that means we have n factors. So factors are the things that are multiplied together. Like if I had 3 times 2 times 5, 3, 2, and 5 are all factors. And anyway, we don't need this part. We are going to read a to the n as saying it's a to the nth power, or simply a to the nth. So that means if I had, as we say down here, a squared, or a to the power 2 is a squared, a to the power 3 we call a cubed. So that is just when we have 2 and 3, but anything else, if I said a to the 5th, we just say a to the power of 5. Okay, so like I said, the only cases where we changed it and not say it, we could say this is a to the power of 2, but we would frequently say a squared. We could say this is a to the power of 3, but we would frequently say a cubed. That's just why that was there. Okay, so examples here. Got to move a few things around. There we go. We just want to rewrite this as an exponent. So if I have 9, we see we have 9 4 times, we would just say 9 to the 4th. We have y's here. So notice that I have my operator of multiplication here. If I write a list of variables and I don't put that operator there, we are assuming multiplication. So we're assuming that this is just this. I think most of you know that. But if you're from out of country, you might not know that we just drop our operators there. But we have y, we have it 1, 2, 3, 4, 5, 6 times. So y is multiplied 6 times. So we say y to the 6. So what your exponents are representing represent how many times the number is multiplied to itself. So when we say 9 to the 4, that was because 9 is multiplied to 9 4 times. So multiplied to itself 4 times. Y is multiplied to itself 6 times. Oops, my stuff didn't erase. There we go. So on your worksheet, if you could just take a moment, pause this, and just go through these and write these out. The one with the fraction, like I said, you're just trying to evaluate, so you're going to expand it, is what we're talking about. So this is, as an example, we have, say I had 2 to the third. That is 2 times 2 times 2. So if I multiply that together, that's 4 times 2, which is 8. So this is just going through the notation and just figuring out how to write these. So try to expand them like that and write it out without a calculator as best you can. And we're going to go through and talk about these. Okay, starting with the first couple here. So based on what we know about fractions, we're going to say that 3 to the 4th to the power 3 is just 3 to the 4th times 3 to the 4th times 3 to the 4th. So notice that we have these parentheses here. Then the 3 is on the outside of the parentheses. So everything in those parentheses is duplicated 3 times. But by fractions, when we have multiplication, we just multiply the tops together. And we just multiply the bottoms together. So 3 times 3 times 3 is going to be 27. 4 times 4 times 4 is going to be 16 times 4, I think it's 64. Okay. Then for the other ones, we have negatives involved. So just to kind of talk about what we do with negatives. There we go. So once again, like I said, those, just threw something, sorry. We got those parentheses there. So we got the parentheses and we raise to the power of 4. So we need one more here. So we have 4 times 4 times 4 times 4. Or sorry, negative 4 times negative 4 times negative 4 times negative 4. Because that was what's in the parentheses. So if we multiply this out, we got negative 4 times negative 4. So these together, the negatives cancel. We get a 16. Same thing here. Multiply these together, negatives cancel. We have a 16 again. So we have 16 times 16. So if you had to use a calculator on that one, that would make sense because I just had to get mine out. Make sure I had this right. This ends up being 256. Now here, we have the parentheses and the 3, and this negative is on the outside. So we're going to still keep that negative on the outside. We are not going to keep duplicating that negative because it is not in the parenthesis. So the negative stays out here, but it's the 10 we get 3 times. So we get 10 times 10 times 10. So that is negative. Trying to count my number zeros, negative 1,000. Okay, so same thing here. We got a negative 3 squared. So notice that's not parentheses. The 2 is acting directly on the 3, so the 3 is duplicated. So we keep the negative, can't do anything about that, and we have a 3 times 3, negative 9. Here we have 1 5 times, so 1 times 1 times 1 times 1 times 1. So 1 5 times is just 1. Here we have that negative again. So remember, parentheses, the negative is duplicated this time. So we can have negative 1 times negative 1 times negative 1 times negative 1 times negative 1. I have to put G over here. So if we multiply these together, like I said, a negative and a negative become a positive. So negative and negative, that becomes positive 1 with these two. Negative 1 becomes another positive 1. And then we keep that last negative 1. So we only have one negative here. We get a negative 1. So just kind of a quick reminder about this. When you're multiplying or dividing, just quickly review on this. If multiplying, dividing, you have even amount of negatives, your end result should be positive. If I have an odd amount of negatives, then my result should be negative. So as you saw here, we had a -4, and this was raised to the power 4, so we had -4 4 times. So we had an even number of negatives, our result was positive. Here we have 5 negatives, and result is negative. So the last one, 0 raised to the power of 2, well, that's just 0 times 0, and 0 times anything is just 0. Okay, we're almost done with exponents here. So exponents of 0, 1, just want to briefly go through this. So for any number a, we will agree that a to the power of 1 is just going to be a, meaning if I had 92 to the power of 1, it's going to be 92. And then there's a typo on the slide here. For any non-zero number a, we agree that a to the 0 means 1. So this should have been a 1 here. So -2 to the power of 0 equals 1. So this one here makes sense. If I say a to the power of 1, that means I just have one a. So it should stay a. So 92 to the power of 1 means I only have 192. Power of 0, that requires us to talk about law of exponents before I can even explain why that one works. So right now, we're just going to say, believe me. So for any non-zero number a, we agree that a to the 0 is just always going to be 1. So anything to the power of 0 is always going to be 1. Okay, so we are going to rewrite these without an exponent. So all I'm saying is just if I have 7 to the 1, what does that equal to? If I have -59 to the power of 1, what does that equal to? If I have 11 to the 0, what does that equal to? And just for funsies, if I have -9 to the power of 0, what does that equal to? So I will pause this. Or you will pause this for a moment, just working these problems on your worksheet, and we'll come back to this. Okay. So 7 to the power of 1 means we only have 1 7, so we keep 7 in parentheses again. -59 to the power of 1, we only have 1 -59, so we write it again. You could have kept the parentheses, but when it's just a singular number, we drop those. Really just keep those parentheses when there's an operator, or and technically there's an operator here. If I have 11 to the power of 0, anything to the power of 0 is 1. Now, if I had -9 to the power of 0, remember this 0 is acting only on the 9, not this negative out here. So this part still becomes 1, but we still have to keep that negative out there. So it's going to be a -1.